Deep within the heart of the U.S. military industrial complex, there exist factories where molten steel flows, engines...
This is not merely an assembly line for conventional weapons. This is the Combat Vehicle Regeneration Center.
Every year, hundreds of M1 Abrams tanks, some having served for over 3 decades, are brought back to these colossal depots.
These vehicles bear the unmistakable scars of war, each telling a story of intense conflict.
Scorched armor from IEDs, cracked turrets, and fire-damaged electrical systems are common sights. Some engines pushed beyond their limits, others simply due for a scheduled overhaul.
As these titans roll off their transporters, a 48-hour classification and evaluation process begins.
Laser scans, sonar, and pressure tests are conducted to determine the exact extent of the damage.
This includes the integrity of the composite armor, the condition of the turret, and the wear on the Honeywell AGT 1500 gas turbine engine. The team also assesses potential frame deformation and the salvageability of the fire control system.
Only after this exhaustive evaluation is a decision made.
Will the tank undergo a complete recycling, partial regeneration, or be disassembled for spare parts?
This precise classification ensures optimal resource allocation and maximum efficiency. The journey for these tanks is just beginning, shifting from the battlefield to the highly controlled environment of regeneration. In these specialized overhaul workshops, the meticulous process of deconstruction begins.
The 70-ton behemoth is first elevated, allowing full access to its complex underbelly and modules. Each module is carefully separated, starting with the colossal turret. The 25-ton turret is a complex subassembly, requiring precise handling to detach.
As it detaches, the sheer engineering complexity of the Abrams is revealed.
Next, the heart of the tank, the gas turbine engine, is prepared for extraction.
This powerful turbine is removed as a single, monumental block. The process is meticulously engineered to ensure no damage during removal. Following this, the intricate drivetrain, tracks, and road wheels are completely disassembled.
The outer layers of composite armor are then carefully stripped, panel by panel.
This allows for a thorough inspection of deformation and internal damage.
What remains is essentially a steel skeleton, primed for the most critical phase, complete recycling and restoration.
Actually, many materials within an Abrams cannot simply be discarded. They are engineered from high-strength steel, titanium.
The recycling process begins with meticulous cleaning and material separation.
Damaged, deformed, or oxidized components are superheated in industrial furnaces at 1600 degrees Celsius.
This intense heat separates the alloys and prepares them for reconstitution. Recovered steel is then remelted, purified, and recast.
This transforms raw recycled material into new armor plates, military-grade bolts, and structural modules.
Every component, down to the smallest bolt, meets stringent military specifications.
The most sensitive aspect involves the classified materials used in the Abrams protection.
These secret composite armor layers cannot simply be discarded or openly recycled.
They undergo ultrasonic grinding, breaking them down into microscopic particles. These particles are then compressed under immense heat and pressure into new, dense blocks.
This proprietary method ensures that the technology remains secure and unreproducible.
Remarkably, nearly 80% of an Abrams materials can be reused in this intricate process, an astonishing feat for heavy weaponry. This sustainable approach underscores a commitment to both operational readiness and environmental stewardship. With the frame and armor renewed, the tank enters its most crucial regeneration phase, module reassembly.
The frame undergoes an exhaustive laser inspection, precise to hundredths of a millimeter.
Subsequently, new hydraulic suspension, tracks, drive wheels, and robust linkages are installed. Every part is brand new, ensuring maximum performance and reliability.
The tracks, vital for mobility, are fitted with exacting standards.
In a separate facility, the AGT 1500 engine undergoes its own rebirth.
Turbine blades are replaced, combustion chambers are renewed, and the super high-speed rotation shaft is rebalanced.
The fuel control system is recalibrated to optimize power and efficiency. Each engine is run through a rigorous test in a negative pressure chamber before reinstallation.
Every parameter must meet or exceed original factory specifications.
With its heart regenerated, the Abrams is ready for its powerful engine to be reunited with its frame.
The reinstallation is a symphony of precision engineering.
Robotic endoscopes scan for even the slightest imperfection, ensuring peak accuracy and safety.
The two-axis stabilization system, critical for firing on the move, is then meticulously calibrated.
New laser rangefinders, FLIR systems, thermal cameras, and advanced sighting equipment are universally installed.
The turret, now a fully modernized combat system, is ready to be reunited with the hull.
The ultimate moment of rebirth arrives as the turret is finally lowered onto the tank's body. This precise alignment marks the physical completion of the Abrams.
Now, the electronic soul of the tank is activated, and a full system diagnostic begins.
This comprehensive check ensures that every component is communicating and functioning as intended.
Before any Abrams is returned to service, it must conquer 3 rigorous levels of testing.
First, static tests verify over 800 technical parameters.
This includes hydraulic pressure, fuel system integrity, sensor performance, and fire control system diagnostics.
Every detail is scrutinized to ensure optimal functionality.
Next, the dynamic tests push the Abrams across 50 to 100 kilometers of diverse terrain.
This includes mud, rocks, sand, steep inclines, paved roads, rugged ground, and simulated urban environments.
Each terrain type tests a different aspect of the tank's regenerated capabilities.
Finally, the ultimate test. Live fire exercises.
The 120 millimeter main gun must fire armor-piercing, high explosive, and training rounds.
Accuracy and stability must meet rigorous U.S. Army standards.
The margin of error must be less than 1%.
Only after conquering every challenge
Is the Abrams truly ready?
It receives the coveted Combat Ready stamp.
These tanks have undergone an extraordinary journey. From the battlefield, through complete deconstruction and recycling, they return to perfect strength, just as they first left the production line, ready to defend. This is how America sustains its formidable armored force with optimized cost. They don't just build tanks, they regenerate them. The M1 Abrams tanks returning from conflict zones often bear the brunt of intense combat. Structural integrity is often compromised, with turrets showing significant damage.
Electrical systems, vital for a modern war machine, are frequently burnt beyond repair.
The powerful Honeywell AGT 1500 engine, having been pushed to its operational limits, often requires complete overhaul.
Even tanks simply reaching their scheduled maintenance intervals require thorough inspection.
Advanced laser scanning technology precisely maps the extent of composite armor damage.
Sonar scans dive deep into the turret structure, pinpointing hidden weaknesses.
Hydrostatic pressure tests evaluate the structural integrity of the main chassis. Detailed analysis of the turbine blades determines the extent of engine wear. The main chassis is meticulously inspected for any frame deformation that could compromise stability.
Diagnostics confirm a critical failure in the sensor array. The fire control system requires immediate replacement.
Each tank is carefully positioned, marking the beginning of its comprehensive reconstruction.
The critical first step in disassembly involves meticulously unbolting the turret from the main hull.
Once detached, the engine compartment reveals a dense network of systems. Damaged armor plates are carefully removed, exposing the underlying defensive layers.
The tank now stands as a bare frame, ready for the transformative recycling phase.
All materials are meticulously segregated, ensuring optimal recycling efficiency.
Recycled steel is transformed into high-quality ingots, prepared for new components.
From these ingots, new armor plates, bolts, and structural elements are forged with precision.
The classified composite materials undergo a sophisticated reprocessing to retain their protective properties.
The tank's chassis is reassembled with laser-guided precision, ensuring perfect structural alignment.
New hydraulic suspension systems are integrated, promising enhanced durability and ride quality.
The AGT 1500 engine receives new turbine blades and a completely renewed combustion chamber.
Its performance is rigorously tested in a controlled environment, ensuring flawless operation. The main gun barrel is internal scanned for any imperfections, ensuring pinpoint accuracy.
The entire fire control system undergoes meticulous calibration to achieve optimal performance.
Dynamic tests include navigating complex urban terrain simulations, pushing the tank's agility.
Live fire exercises test the tank's offensive capabilities, engaging multiple targets with accuracy.
Every round fired is analyzed, with accuracy confirmed to be less than 1% error.
The regenerated Abrams stands as a testament to unparalleled engineering. ready to face any challenge.
This facility is not just a factory, it is a crucible of rebirth, ensuring America's armored might remains at the forefront of global defense.